In this video, we are looking at the geometric sequence with a second term of half. So they say the second term is half. So let's see. We are given that the second term is half. So T2, which is the second term, they say its value is half. Right, and then we are given that the pattern is geometric. Okay, then they say the ninth term, which is T9, is 64. Okay, perfect. So now we're going to use this formula. Tn equals to A dot R to the power n minus 1. Right. So I know that, okay, T2 is equals to A times R to the power 2 minus 1. So I replace the n with 2. And I know that T9 is the same as A times R to the power 9 minus 1. I replace that with 9. But the value of T2 is half, so I'm going to put half here. Equals to A R to the power of 1. Right. Term 9 is 64. Is the same as A R to the power of 8. All right. Now, guys, once you are on this step where you have substituted both the n and the value, you can now declare that this is your first equation, and then this is your second equation. Right. And there's one method that always works for me when I'm doing a simultaneous equation. Obviously, I know that it's simultaneous because I have two equations and two unknowns. And the first one, they want me to calculate the value of R. The second one, they want me to calculate the value of A. So which are the unknowns in these simultaneous equations? So this is the most important part, NB. For simultaneous equations of geometric, you're always going to take a bigger equation. In this case, 64 is bigger than half. And then you divide it by the smaller one. That is very important. A bigger, let me just say big, divided by small. For geometric pattern, this is how you are always going to do your simultaneous. It is very easy to do it that way. So now you have the bigger one is 64 over A R to the power 8, and then we divide him by the smaller one. This side we have half, so 64 divided by half. Then this side we have AR, right? Now, you'll see how easy it gets. Once you do that, we can easily get 64 divided by half, which gives us 128. 128. And then this side, the A will cancel the A. And then R to the power 1 at the bottom, R to the power 8 on top, results with R to the power 7 using laws of exponents. When dividing the same basis, you minus the exponent. So 8 minus 1 is 7. And then we can see that, okay, 128, you have it on your calculator as the answer, and then you say shift, you press fact. You can see that this can be written as 2 to the power 7. It's R to the power 7. And since the exponents are the same, they can cancel each other, right? So you're left with 2 equals to R. So you have the value of R as 2. Now, you can easily get the value of A by either substituting here or there. But in this case, I'll just substitute there. Or I'll substitute on both just to showcase that we're going to get the same answer, right? So here I have half equals to, where there was R, I'm going to put 2. Right, so it's A times 2 because your R is 2. And then what do we get? You are going to basically divide by 2 both sides, which is the same as multiplying by 1 over 2 both sides, right? And then that gives us 1 over 4 equals to A. Right, now let's check this one. Let's say you substituted your R here. You're gonna get 64 is the same as A and then 2 to the power 8. You need to divide by 2 to the power 8 both sides. 2 to the power 8. And then you know that, okay, 64 is 2 to the power of 6 over 2 to the power of 8, which is A, that side. Therefore, you can see that this will be the same as 8 minus 6, which is 1 over 2 to the power 2, which is 1 over 4 still. Right. Perfect. So I'm sure we got that, ladies and gents. Now let's check what is there. Determine the general formula of the sequence. Okay. The general formula will be basically Tn. Our A is 1 over 4. So 1 over 4. And then our R was 2. And then we have N minus 1. And that's it, ladies and gents. That is the formula of the nth term. Right. Perfect. Then now we can go to the next one. Let us go to the next one. And in this question here, they want us to basically, let's see. They say the diagram shows 4 sets of values of consecutive terms of a geometric sequence with the general formula, the normal general formula, right? Perfect. So in this one here, we can see, ladies and gentlemen, that the first term is y. So I'm going to write them here. The first term is y. The second term is x. The third term is 1. The fourth term is 2. Right. And then they want us to determine the first term and the constant ratio. Okay, that should be an easy thing to do because we know that, okay, I can easily get x. I'll show you now. You have term 1, term 2, term 3, and term 4. So here you know that term 2 over term 1 is the same as, this is your ratio and that is your R, is the same as term 3 over term 2, which is the same as term 4 over term 3. That is your constant ratio, the R. So now we can substitute. We know that, okay, term 2 is basically x. Term 1 is y. And then term 3, it's 1. Term 2, it's x. Equals to. Term 4 is 2. Term 3 is 1. So from here, I have 3 ratios. And then I'm going to be smart when I select them. Ne? So here I can easily see that, okay, this ratio here will help me because it only has one unknown. So it's the easier one to work with. So I'm going to say, therefore, 1 over x is equals to 2 over 1. Then I cross multiply. 1 times 1 will be 1. And then I have this times that gives me 2x. And then we can divide this by 2 divided by 2. You can see that therefore x equals to half. So the x value is half, ladies and gentlemen. Right. Perfect. And then when we have this, remember this is R, right? I can easily see that, okay, here I have nothing. Here I have no information. But here the answer is 2. So I can easily see that, okay, my R will be 2. Do you see it? Perfect. And then now I just found the value of x. I can easily substitute in here and there and use this to get my y, which is the first term, which is my a. Remember, a is the first term. So I'm going to say, okay, x is half. So I have half divided by y is the same as 1 over half. So I substitute x there and there. I cross multiply. I have 1 over 4 because half times half. And then I have 1. I mean y because of that and that. Right. Then I can see that therefore my a is a quarter. And my r is a 2. Right. So I found my a and my r. I also found my x and my y. Now I can easily find the fifth term. Remember, I know that therefore Tn is basically a dot r to the power n minus 1 then you know that, okay, I'm looking for term 5. So n is 5. My a is a quarter. My r is a 2. And then my n is a 5. Then I need to minus the 1. Then the fifth term will be what? Will be in a calculator, you have 1 over 4 multiply by 2 to the power 5 minus 1, which is 4, right? So 2 to the power 4, which gives you 4. So the fifth term is 4. And you could have also seen that since your ratio is 2 and you have the fourth term, you have the fourth term here. So the first term times 2 gives you this value here. And that's finito for this video, ladies and gentlemen. Thank you for watching. Don't forget to hit the like and subscribe button and to share with family and friends. Thank you very much. Aluta continua. Tango.